Alright, so I'm going to do a couple problems. So this is going to be a long video because I want to show you not only the question that was asked, but a more generic question. Okay, so first of all, I'm going to just do it the way it was written. Two people start from the same point. We may as well make it the origin. One rides bike east at 5 miles per hour. So this cyclist is going to be going 5t in the x direction and nothing in the y direction. And the other guy is going to be going north, so the x direction doesn't, the x position doesn't change, and then the y is going to be 12t. Right? An awful lot of people just said the answer was 13 because they recognize the 5, 12, 13 right triangle, but that only tells you their initial distance. So there's a huge difference between what are two people's distance and what is the change in the distance between them. Okay? So that's the first problem. The 15 minutes is just t equals 0.25 because it's a quarter of an hour. That was the least of our issues on this problem. Okay, so if we want to find the distance between any 2 points, okay, is the square root of what? It's going to be x1 minus x2 squared plus y2 minus y1 squared. So distance is, this makes it easy. So it's 5t squared because the other guy is 0, so we don't have to worry about subtracting him. And then it doesn't matter if you switch the order because you're just going to square this thing anyway. You end up with 169t squared inside the square root, and that actually all comes out as 13t. So what it actually means, it doesn't, at t equals 0, the distance is 0. At t equals 1, the distance is 13. Alright, so the question asks how fast is the distance between them changing? And it ends up that it's always 13. And this is why this problem is not complex enough. But the answer would have been, oh, at 13 miles per hour, actually. And it's the same whether it's after 15 minutes or after 20 hours. It doesn't matter. That's how fast the distance is changing. So for that question, that was the end of the question. That would have been full credit. But let's ask a different question that's more generic on these same axes. Alright, let me just erase this mess. Alright, I'm going to ask a question. I'm going to change it. Okay, so I'm going to say one person is going to ride bike or whatever at northwest at 2 miles per hour, and I'm going to put them 3 miles between them. And I'm going to make the other one travel due north at 5 miles per hour. That's going to be my setup. And I'm going to say how fast is the distance changing at t equals 0. Because this problem is going to be messy enough that just calculating at t equals 0 will be plenty of trouble for us. Alright, so what is going on here? Well, if you're traveling at 2 miles per hour at northwest, then this is what your triangle looks like. You're going, okay, 45 degrees here. And so if this is 1, this is going to be, this side is cosine of 45 degrees. This one is sine of 45 degrees, but this is actually going to be minus. That direction is going to be minus in the x direction. This happened to be something we already know. If we didn't know sine and cosine of 45 degrees, then we go look it up on our calculator or something. But this is just minus 1 over root 2. This is 1 over root 2. But it's not what it said. It said you're going 2 miles an hour. So we're like, oh, no, it's 2, it's 2, it's 2. So we have to multiply this whole thing by 2, and then this is 2 on this side, okay? So what's happening is this guy right here has a position of, the x is minus 2 over root 2 t and 2t over root 2. And you may think that's really messy. Yeah, let's clean that up. It's not required, but we can clean that up because 2 over root 2 is just root 2. There's minus root 2t and root 2t Whereas this guy is really easy. He's just going north. So his x position is always going to be 3, and his y is just 5t. Okay? So we've got both of these guys figured out. I'm going to erase this so we can have more room to write. Now I want to know the distance between these guys, and I'm going to use the same formula as I did before. And it's going to be x1 minus x2, and I'm going to square it. But actually x2 minus x1 in this case is just easier. 3 minus a negative root 2t. And then the other component is going to be 5t minus root 2t, and I'm going to square it. Okay? Now it looks like a mess. Well, it is a mess. That's why you're only going to evaluate it at t equals 0, and you're just going to leave the mess as it is. But that's the distance. So what's the derivative of the distance? Well, I'm going to go ahead and write distance with a 1/2 exponent so that you can see this a little more easily. 1/2 of all this, what is this? Edit, copy, paste. So what's going to happen to this exponent? It's going to turn into a negative 1/2 because I just subtracted. And I'm going to just move this around a little bit so that you can see what's going on. Okay. Now, I have to multiply by the derivative of what's inside, and that's going to be nasty. But I'm just going to be slow and careful about it. So each piece I have to worry about. So 2 comes out front, 2 junk to the power of 1 times the junk inside's derivative. And then the second piece I have the same issue. 2 junk times the derivative of the junk inside. Now the junk inside is 5 minus square root of 2. And there you go. And that is how fast the distance between them changes. But what happens if I evaluate it at t equals 0? So this notation I just used is one way of writing that. Or you could say dist prime of 0. Both of those are correct. Alright. So I'm going to try putting in 0. What do I get? 3 squared plus, oh good, that is a 0. This whole mess turns into a 0. Great. That's why I did it. Minus 1/2, okay. 2, 3, root 2. Oh good, the next piece, this is 0, wipes out that term. Awesome. Now we try to figure this out. We have 1/2. Now 3 is squared, but then we take the square root and put it in the denominator, so that's fine. And then the numerator up here we're going to get a 2 times a 3 and times a square root of 2, and all that is going to give us a square root of 2 miles per hour. And I think that's correct, although I did it in my notes and I got a different answer, but I think I was doing it too quickly. How did I get a 9 over here? Somehow I got a 9 over here in my notes, and I think that was wrong. I think that's supposed to be a 3 over here. Okay? But this is just pointing out why you want to leave all your work. Because say this is wrong. I don't know. Maybe I made a clerical error. I don't really know. But maybe there's a clerical error. But this amount of showing your work, you're showing all this. This is what you want to do. Because if you make an error here and this is how close you got, you'd only lose a point at most. Because the process is clear. If your process is clear and you make an arithmetic error, like a really small error, then I can forgive that because I know what you did. I know why you made the mistake. So try to communicate with me so I know what your process is, and that will help you capture the most points.